First neural network, very simple maths, very simple, absolutely simple. The only thing you need to understand is this is a structure which has stood the test of time, and this is the basic cornerstone of the whole deep learning. And this notion is what is known as perceptron. Perceptron is the basic architecture of an artificial neural network where you are imparting a behavior which is way different from any conventional machine learning algorithm. Where does that difference come from? We will slowly explore today. Today will be the discovery of why this proved to be successful, why this has proven to be so generic. So let us examine what does it contain. In the simplest of the examples here, we have input data x1, x2, xn. Then we have weights corresponding to each of the connector to, this is called as an activation point. And once you get the sigma of wi xi, here you perform a nonlinear function. We call it thresholding. Thresholding, you understand from technical terms? If something crosses a threshold, you say is 1. If something is less than the threshold, it becomes 0. Okay? So now think about this. Let us, for convenience sake, we typically add a constant layer also, not just a variable. There are n variables, then there is a constant layer called as C. Then it becomes, let us call it W0. Then this becomes W0 x0, x0 being constant, W1 x1, W2 x2 till Wn xn, sigma of Wi xn. Then you see what the values come. Then depending upon your threshold, you say that you either output 1 or you output 0. Very simple structure. Think about it, but this is very powerful. It can capture many common functions. So now I will ask you to do a series of exercises. I hope, can I get, let me see if I have an exercise here. Okay. Let us assume we have a function called AND. What does AND do? AND takes two inputs, x1, x2, and gives results like this. Right? You agree? Now, let us assume that we are trying to draw a x1, x2, then x0, which is a constant. Right? And there is this connector which connects to sigma wi xi. Right? Then there is a threshold k. What is the threshold? It specifies that if sigma of wi xi is greater than or equal to k, give me 1. If sigma of wi xi is less than k, it gives you 0. Now you have to think about this function x1, x2. The final output should be what AND should give it. So draw the structure in your thing. Draw a structure like this: W1, W2, W0, x1, x2, constant. Then, depending upon k, you will get the output. Now think about what is the 4 rows which define AND function. x1 is 0, x2 is 0. What is the output? 0. If x1 is 0, x1 is 1. 0. If x1 is 1, x2 is 0. 0. x1 is 1. x2 is 1, output is 1. Now you tell me what will W1, W2, W3 and K be if you are to implement with this kind of a formal method, what will K and what will W1, W2, W3 be? I think it's very simple. If it is 1, 0, it is W1 plus 0 plus C. Subject to K, it will give you 0. Same way it is 1, 1, W1 plus W2 plus W3. Subject to K, it should give you 1. Understood what to do? Very simple. Think about W1, W2, W3 and K combination, which is going to give you the AND function. Understood? You give me K, W1, W2 and W3. There can be many answers, not one. Many possible combinations of answers.
The 3 inputs are the 3 AND gates.
W1 into 1, x1 is 1, right? Suppose. Then W2, x2 is 1. So W1 plus W2. Plus you need a W0, right?
W0 is what?
W0 is a bias into 1. This W0 is always 1. So whatever is x0 you get, you can think about as 1 and W0 whatever you put. So W1 into x1 plus W2 into x2 plus 1 into W0. This is you can think about x0 as 1. So W0 plus W1 x1 plus W2 x2, you take that sum, compare it with K. Think very simple data, not very complex. Think normal numbers to think about it. For W1, W2 and W0. What answer?
Like, K should also be represented in binary digits or decimals?
No, it should be numbers. Anything, any number is fine.
No.
As long as it gives the answer to AND function.
Like it's 1 point something.
So it's fine. Are you able to get an answer for W1, W2, W3, W0 and K? Can one of you tell the answer?
Each of W is 1 and K is 3.
K is 3 and okay. 1, 1, 1 and 3 and remaining if you see 0 anything. So that's also fine. You have got it? W1 equal to 1, W2 equal to 1, W3, W0 equal to 1. If you add all the 3, it becomes 3 greater than equal to 3, so it gives you 1. Any one of them is 0, it falls less than 3, so it is